and phi for this particular example here. So say we are given x equal to 1 and then x dot equal to 0. So we see how to solve for x and c. So in this way, we can have a complete description of the solution here. So with this one, you can see the first one is x dot equal to 1, and then what is our solution here? So let me rewrite here one more time. So not to confuse myself, xt will be equal to e minus 0.2t times capital X and cosine beta t 3.56t minus phi. And so therefore x initial conditions equal to 1, x dot equal to 0. So we solve for x and phi. Okay, so that is our problem statement here. So using the initial condition 1 equal to x0, so that one we can plug in. So that means when we introduce t equal to 0, so that's a capital X times cosine minus phi. So basically that is capital times cosine phi. Yeah. Okay. And here we're going to do a little bit calculations. X dot based upon this one, and here we have two terms, t and t here, so we're going to take the partial derivative and turn by turn. So for the derivative based upon this one, I will take the derivative on this exponent first, so minus 0.2, and multiply x minus 0.2t times x and cosine 3.56t minus phi. And then I apply the chain rule to the second one, so e minus 0.2t times x multiplied then to this root is 3.56, and then the derivative on cosine is minus sine. Okay. So let me rearrange it. So that will be minus point whatever. I don't want to spend time to rewrite that one. So in this way, the initial conditions on the velocity equal to 0. So we simply introduce t equal to 0 in these whole terms here. So that is minus 0.2 times x and times cosine and minus phi equal to phi. Okay, and then plus x times 3.56 times and minus sine and minus phi. Okay. I don't have a preparation for this example, and you help me to double check my calculation is correct or not. Should be right, right? Okay, and these are minus and multiply with sine minus phi, so why not we take the minus out and take this kind of out, and to help us to kind of be easy seeing the whole things. Okay? Good? Okay, so right now with the equation, let me call this is equation 1, this is equation 2. So from equation 1, so from equation 2, basically here you can see x times cosine phi equal to 1. So here I'm going to introduce 1 equal to here. So let me further simplify. 0 equal to minus 0.2 plus, this one is capital X, 3.56 times sine phi. Okay, so under these situations, therefore 0.2 equal to 3.56 times x sine phi. So that means 0.2 divided by 3.56 equal to x sine phi, right? And this one basically, again, I introduced to here, and then I directly I move this term to the left-hand side to have this one. You good? So to this step, let me call this equation 3. So with equation 1, let me rewrite equation 1 here. So 1 equal to x cosine phi. Good. With the two things, if you do the compare, you do the ratio on the both sides. So that means from here, will that be equal to 0.2 divided by 3.56 divided by 1 will be equal to x sine phi, x cosine phi. Right, I simply divide the two equations on the either side. We have this one. So basically this is equal to tangent. See? So from here, tangent, the phi, you can obtain the phi equal to arctangent. And 0.2 divided by 3.56. Anyone have a calculator? Can give us a number for this? That's arctangent 1 over 18. 1 over 18, sine 18. I guess that is about 22.
Do you want degrees or radians?
Degrees.
Oh.
Either way, either way.
Okay, in radians it's 0.0561.
Okay. So with phi be resolved and this solved, then you can solve for x pretty easily from the equation 1. Okay. So this one, basically, once you have this one, we completely solve these problems and with that particular initial conditions here. Okay, so today with exact timing, today we stop here, and then coming back Wednesday, we will gradually